Hello everyone, welcome back. Today we are going to start lecture number 2 of environmental engineering, and I hope you all must have watched my previous video which was about lecture number 1, in which we discussed the importance of environmental engineering as a subject in GATE and other exams like ESE and SSCJE. And today in this lecture we are going to revise a bit of the previous concepts. I want to give you a quick glance of the whole of the environmental engineering, what we actually do. Actually we have a source. We have a source from which we actually collect the water and we supply it to the community, and that's what we had discussed in the previous lecture. And the whole of the engineering that's involved in collecting the water and then supplying it to a community, because water is essential basic need of life. It has to be supplied to a community or a city wherever you are living, and the whole of the engineering that's involved in collecting the water from the source and then transferring and providing it to whole of the population, it involves raw water engineering. Okay, and when this water is used by the community, when this water is used by the population, and it is discarded as a waste in the form of sewage, and the whole of the water and which is collected systematically, that we will be studying, and the whole of the engineering that's involved in collecting the waste and then treating it, and then obviously discharging it in the source again for natural purification. The whole of the engineering that's involved in it is called wastewater engineering. Okay. Now today we are going to take up sources. As I had already mentioned, that sources are of two types. We have subsurface sources, we have surface sources. Okay. Today we'll be discussing about some of the geological formations which are the subsurface sources. So guys, today we are going to discuss about subsurface sources. Sources of water. Let me mention it over here. Topic is sources of water. Sources of water. And in sources of water we have surface sources and we have subsurface sources, obviously. Subsurface sources. Now today we'll be discussing about the subsurface sources, and in subsurface sources we have actually geological formations, like aquifers, and then we have obviously infiltration galleries, which are the horizontal tunnels which are actually constructed besides a river or a stream, infiltration galleries. And we have wells. So today we'll be discussing about the aquifers. Now about aquifers, let me mention it over here, aquifers. So our topic is geological formations, and I'll write over here aquifer. Aquifers. Now what aquifers are? These are the types of geological formations which are both porous and permeable. What we mean by having porosity and having permeability, these are both, I will mention it over here for now. These are both porous and permeable. Permeable. Okay. Now see guys, these two terms, obviously you know that what's porosity, it's the volume of white stuff, total volume of soil, and permeability is the property of soil with which it actually allows the movement of water in it. Okay, so the porosity and permeability. Okay, we need to understand the physical significance of these two terms. Porosity is actually how much volume you have of voids, and those voids are either occupied by air or water. Okay, so in any soil strata we have voids. Okay, now the voids are actually you can say those are actually tanks. The voids actually represent the tanks where you can store either water or you can store either air. Okay. Now, so porosity gives rise to the water storage capacity of a soil strata. Now you have different soils. You have obviously you have clays, you have silts, okay, you have sands, you have gravels, okay. Now any of a geological formation can be present inside the earth. So if it's a clay, it will be having different porosity, different permeability. Silt, it will be having different. Obviously, if there's a geological formation of sand, so it will be having different porosity, different permeability. Now, what actually aquifers are made of? Actually, the aquifers are both porous and permeable. Now, if I talk about clays, okay, clays are very fine. They are fine grained soils. Okay, they have a lot of porosity, but their permeability is very low. Okay, about silts, they obviously have a lot of porosity and they have more permeability than clays. Okay, and then we have sands. Okay, now about sands. Okay, sands are highly permeable. They have high permeability if you compare them with the clay, because we don't have absolute values. Okay, we can compare different types of soils over here. Now sands have higher permeability than clays, but they have less porosity. Okay, so their what I can say, their water storage capacity is lesser than clays, but they can actually drain out water. You can actually draw water. You can actually draw water. So aquifers are obviously, they are having both porosity and permeability. Okay, and in geological formations, if we have fine sands, example, if we have fine sands or coarse silts, these two geological formations, if present in the earth, they actually form aquifers. Okay, so they will be having two properties. Number one, they will be having water storage capacity. Okay, and number two, you can draw water from them. You can obtain water from them. So this is the property of aquifers. Okay, now aquifers are of 2-3 types. Okay, now we have confined aquifers. Types of aquifers I must write over here. Let me write over here. So types of aquifers. If I talk about types of aquifers, we have 3 different types of aquifers. First is unconfined aquifer. It's also called as water table aquifer. I hope this is not coming out of the board. And second is confined aquifer. Okay, this is also called as artisan aquifer. Artisan aquifer. And third is perched aquifer. See guys, I will draw a random geological terrain over here, where I will define what unconfined aquifer is, confined aquifer is, and perched aquifer is. Let me draw it over here like this. If I draw over here like this, okay. If I have geological formation, if for example is a well I have created over here to check where the water table is located, okay. So if this is a well, okay, and this is a stream or river or lake, whatever it is, okay. So I have found that the water table is here. Now, if I talk about unconfined aquifer, okay, unconfined aquifer's location will be obviously in this range. For example, if this is a impermeable layer, present at some depth inside the earth, and if you have a geological formation of fine sands and coarse silts over here, okay, so you will call it as unconfined aquifer, because it's not confined. Okay, and if we talk about the other properties of unconfined aquifer, the water in this it's not subjected to atmospheric pressure greater than hydrostatic pressure. Okay, this the whole of the water which is present in the unconfined aquifer has the pressure equal to hydrostatic pressure. Okay, if for example I have a simple strata, that's fine sand and coarse silt present over here. Okay, and there's one more impermeable layer present here. Okay, so I will call this as confined aquifer or artisan aquifer, as I have mentioned here. So this will be unconfined aquifer. So you have to you just as the name indicates, it's unconfined. It's not confined between any two impermeable layers. Okay, the confined aquifers are actually they are sandwiched between two impermeable layers, and those are also called as artisan aquifers. Now, artisan aquifers are actually, they can be the pressure present over here can be more than the hydrostatic pressure. Okay, obviously, because it is not open to the atmosphere. Okay, obviously there can be pressure build up. The pressure can build over here, and if that pressure actually exceeds the shear strength of the strata, it can burst out. Okay, it can burst out. So basically what I want to say is that this sort of water over here is present in the confined aquifer can be subjected to pressure greater than hydrostatic pressure. Okay, now what about perched aquifer? As I have mentioned over here, perched aquifer, in some cases, if you find, for example, if you have a strata over here, this is the water table, okay, and this is the water table, original water table. If I draw it somewhat like this, for example, my strata is like this, okay. This is the same strata, just to have some space over here to show you what perched aquifers are. Now, if I have a material of fine sands and coarse silts present over here, okay, and I have a limited impermeable layer present below it, okay, then I can obtain water from this source. Okay, for example, if I draw a well, okay, if I dig a well over here, and I can draw water from this aquifer, if it can be large. Okay, now this sort of formation is called as perched aquifer. This sort of formation where we have a limited impermeable layer above water table. The water table is over here, and above that water table I have a limited impermeable layer, and above that impermeable layer I have a geological formation of fine sands and coarse silts. Okay, this is called as perched aquifer. I hope everyone is understanding it. Now, one more important thing that I want to discuss about with you about the actually confined aquifers is that we actually get the storage coefficient equation in some exams like GATE and SSCJE exams, even ESE. In ESE it has been asked. So let's move to that part. Okay. What about the storage coefficient of confined aquifers? And before mentioning the equation, I want to discuss about the storage coefficient. Obviously, now storage coefficient, and we denote it generally by S. So what is storage coefficient? Storage coefficient is if for example, if I talk about a confined aquifer, it is the volume of water which is released by the column. For example, of unit cross-sectional area under a decrease of under a unit decrease in piezometric head. For example, if I say it like this, if I have a confined aquifer, and if I take a column of this confined aquifer of unit cross-sectional area, 1 unit square, 1 unit area, for example, if I talk about the 1 unit area cylindrical specimen of confined aquifer, okay, and the amount of water which can be released, which can be released. If I am drying water from it under a piezometric head decrease of 1 unit, okay, that amount of water is called storage coefficient. Okay, so I hope everyone has understood. We have to take a unit cross-sectional area, okay, a unit column of water released by a column of confined aquifer of unit cross-sectional area under a unit decrease in piezometric head. So the storage coefficient equation is given by S is equal to gamma n beta plus alpha into B. Now this gamma is obviously rho into D, sorry. Okay, that is the weight of unit volume of water. And it is the porosity. Beta, it is the compressibility of water. Compressibility, this is porosity. Compressibility of water. Alpha represents compressibility of pores. Compressibility of pores. And B is the thickness of the aquifer. Is the thickness of aquifer. So just have a good look on this equation. Many a times this equation has been asked recently in many exams like SSCJE, even ESE and maybe GATE. I'm not sure about whether GATE has asked it or not, but about SSCJE and ESE this equation has been asked. So just have a good look on it. If you want to write, just write and pause the video, you can write it. Now moving ahead, we have other formations besides aquifers. Now about aquifers, you must remember one thing, that is what? That's fine sand and coarse silt. Aquifers are made up of fine sands and coarse silt. Now we have a second geological formation that's called as Aquiclude. Now what about Aquiclude? Aquiclude are simply clays. If we have a geological formation of clays inside the earth, we call as Aquiclude. Now, before studying Aquiclude, we should obviously know the properties of clays. Now, what are the properties of clays? They obviously have high porosity. When we compare it, when I talk about the geological formations over here, I compare them with the aquifers, because aquifers are like, they are taken as a standard geological formation because they are useful to us. Now, when we talk about aquicludes, since they are clays, and if we compare them with aquifer material is what? It is fine sand or coarse silt. Now, since if I compare fine sands and clays, now if I talk about the porosity, obviously these have high porosity, so they can actually retain, they can actually store a lot of water than aquifers, than fine sands. Okay. Now what about the permeability? Because we have to, if they are going to store the water, now we have to actually, we are talking about a source of water, so it should be a source. But if I talk about the drying capacity, if I talk about the permeability of clays, that's very, very less. Okay, so it will take a lot of time to draw water from an aquiclude than an aquifer. Although aquifers will store less amount of water, less quantity of water, but the drying capacity from the aquifer is much higher than aquiclude, that's clays. Okay, so they have less permeability. Okay guys, so this was all about what we mean by aquiclude. Now moving further, and we have a third formation that's called as Aquitard. You can write, just pause the video, you can write all these things. These are very important things and they have been asked many a times in exams. Now, Aquitard, if I talk about the Aquitard, those are the formations of sandy clay. When we have geological formations of sandy clay, those are called as Aquitards. Now, if we study about the sandy clays, obviously the porosity will be less than the aquiclude. Obviously, when we are talking about aquiclude, that's glaze. Okay. Now, if I compare the sandy clays with clays, obviously the porosity will be less. Porosity less, but more permeability. And if I compare them with the aquifers, okay, these will be having more porosity. These will be having more porosity but less permeability. Okay. Now what about the other geological formation that's called as Aquifuge? Now, Aquifers these are the formations which are neither porous nor permeable, like rock. If we have a rock formation over in the soil, you can say that as Aquifers. So these are not important. Now, if I compare all the four, for example, let me write over here neatly. We have aquifers, we have Aquiclude, third is we have Aquitard, and fourth one is we have Aquifuge. Now, what is aquifer? These are simply fine sands and coarse silts. What about Aquicludes? These are clays. And what about Aquitard? These are sandy clays. And what about Aquifuge? It's simply a rock formation. Okay. Now, if I compare the maximum permeability and porosity in them, okay. If I tell you, just write these four in higher order of permeability. Okay. Now, what will you write? Permeability. Permeability will be maximum in aquifers. So, if I talk about the permeability order, so aquifers first. Aquifers will be having the highest permeability, and then what guys? Aquiclude or Aquitard? Okay. If you are saying Aquitard, then you are right. Okay. So Aquitards will be having lesser permeability than aquifers, but higher permeability than Aquicludes. Then obviously we have Aquicludes, and then we have Aquifuge. I hope this is not coming out of the board. Okay. So this is the order of permeability in all these geological formations. Now, what about the porosity? Tell me, guys. Yes, which will be having highest porosity? Yeah. Obviously, the clays will be having highest porosity since they are the finer soils among all the four. Okay. So finer the soil, more the porosity. Now, about the porosity, obviously, permeability order. This is the porosity order. I should mention over here if you are making notes. Porosity order. Now, so Aquiclude, that's clay, will be having the highest porosity among them. Then which will be having the second highest porosity? Obviously, we have clays over here. So these are sandy clays, so they will be having lesser porosity than Aquiclude, but higher porosity than aquifers. So we have to write Aquitard, and then obviously aquifers, and then Aquifuge. Aquifuge is a rock. It will be neither porous nor permeable. So this is the porosity order, okay, and this is the permeability order. So I hope you have enjoyed today's lecture. Okay, we'll be bringing more lectures, and in next lecture we'll be talking about wells and infiltration galleries. Hope you are liking the content. Just subscribe to our channel if you have not subscribed yet, and press the bell icon for the recent notifications. And please share our channel. Thank you very much.